Hi, I am Lalchand, and in this video I am going to explain block diagram of 8085 microprocessor. So to remember block diagram of 8085 microprocessor, it is difficult to memorize it, isn't it? So let me explain you in simple way, and I am trying to make it very simple to memorize it. So how to memorize 8085 microprocessor block diagram? So for this I will suggest you microprocessor is nothing but one programmable advanced electronic calculator. Okay, so if I will ask you how to make one electronic calculator, so can you make electronic calculator? Just think that to make electronic calculator, what we need? So we need one arithmetic operator, means thus such one type of circuitry or one block which can perform arithmetic operations. So in this block diagram we are not going to discuss about complications of the circuitries, just we are discussing here blocks only. Just take one block which will perform arithmetic and logical operation. Okay, so here is our arithmetic logical unit. So in this block, one 8-bit full ladder, binary full ladder is inside this block, and arrays of 8 logic gates, that is AND gate, OR gate and XOR gate, so which will perform logical operation, and one 8-bit binary full ladder which will perform arithmetic operation. Okay, so just consider this is a block which will perform arithmetic and logical operations. To perform any arithmetic or logical operation, we need at least one or two operand, so we have to store somewhere else. So for that we should have one register. So here is the register called accumulator. So register is nothing but group of flip-flops. So if it is 8-bit, so there are 8 flip-flops are connected parallelly which can hold 8-bit data. Another one register we required for store the another operand. So here is another register, that is called temporary register. So it is also 8-bit long. Now we will apply these two operand to the block which will perform arithmetic or logical operation. So here is accumulator is applied to the ALU and temporary register is applied to the ALU. Now what will happen? This ALU will perform any arithmetic or logical operation. It depends on the program what operation we want to perform on this data. Okay, so this will be selected by any control signal and a circuit selection signals. Okay, now this will perform the arithmetic or logical operation and give us one result. So it will give the result, we have to store somewhere. In this case we will store in accumulator. So accumulator and temporary register will be connected with the one bus that is called internal data bus, 8-bit long. Okay, if we want to perform any arithmetic logical operations on various data and we want to store some other data, so we need again a group of registers. So these registers are here. We have 8-bit register called B, C, D, E, H, L. Okay, and another one is flag register. Let me tell you about B, C, D, E, H, L. So these are again 8-bit registers, 6 general purpose registers. So where we can store the data. We can store means we are the programmer of this electronic calculator, and we want to store the data inside this calculator, so that these registers will be required. B, C, D, E, H, L. So B, C, D, E, H, L registers are 8-bit long. If we want to store 16-bit data, so how can we store this 16-bit data? So we can make pair of these registers. So pair of B and C, it will able to store 16-bit number. DE will able to store 16-bit number, and HL will store 16-bit number. So if we want to store 16-bit number inside this calculator, so or inside this circuitry, so we have 3 different pairs. Okay, now what is flag register? So whenever any arithmetic operation, arithmetic or logical operation performed, we have to take care of the status of output. So what is result is coming out, so what will be the status of that? So that status should store inside one register. So here is flag register. It is also 8-bit long. So flag register also is group of 8 flip-flops which is able to store the status of your result which is coming out from the ALU. Okay, and it is directly connected to ALU, so that after performing any operation, the status directly reflected to the flag register. This is complete basic digital electronic calculator. Now it's time to make it intelligent. So how any digital circuit will be an intelligent circuit? So it will be intelligent when we will give it codes or programs. So it should be programmable, isn't it? So for making it programmable, we have to make some changes in this circuit. So what type of changes this circuit will need? So whenever we want to make it programmable, so we have to write the program and store into the memory. Because of inside this IC or inside this circuit, we cannot store much long data, means we cannot store large data. So whenever we write the program, so obviously the program length will be larger than 8 byte or anything 10 byte. So we cannot add as much storage inside this IC. Okay, so we have to make one provision to store the program outside of this IC. So that IC, outside of that IC is nothing but memory. So in the memory we will store instructions or program. Whenever these programs will be stored into the memory, this circuit should tell about the address of that memory, so that the instruction stored at particular address should be read or fetched by this circuit or by this IC, and then it should decode it, and after decoding it, it should perform according to the instruction or program, isn't it? So what type of modification we need here? So we have to add one register called program counter and stack pointer. So these registers are 16-bit long, so that it can generate 16-bit address. Okay, so program counter is the register which will hold the address of current executing instruction. Address of that location should be pointed by program counter. Now this program counter will give us one address. This address should load on the address bus. So we need one external address bus or address lines. So here there are 16 address lines called A0 to A15. So we need 16 pins for transmitting the address toward the memory. After sending the address, so one location of memory will be selected, and the data or instruction at that particular location will load on the data bus, and that data bus should connected with this IC also. So we need another 8 lines. So these 8 lines and 16 lines of address, so total will be 24. So if we will separate these lines, so size of this IC will increase. So that what we can do is we can multiplex that 8 lines on address bus, because address and data will not simultaneously transmitted by this IC. One time only address will travel by the bus, and another time only data will travel from this bus. So what is the need of separate address and data bus? So what we will do, we will multiplex data and address bus together. So here is AD0 to AD7 means address and data bus. So these 8 line will carry address as well as data. So now come to the point, our instruction which were stored into the memory, that instruction will be loaded on the data bus. Now this data bus will carry instruction inside this IC. Now what to do with this instruction? So we need to store these instructions in one register. So we need one instruction register. Now this circuitry should decode this instruction. So for that we have to add one circuit which can decode these instructions. Okay. So after decoding these instructions, we have to generate timing and control signals, so that our blocks of this IC should perform accordingly. So for that we need one timing and control unit. So this timing and control unit, it will generate timing and control signal and spread throughout the blocks like this. So these are the control lines, means red lines shown in the figure are indicating control bus or control lines. Okay, now this much circuit is able to read the or fetch the instruction from memory, decode them and generate timing and control signals according to the instruction, and now this circuit or this block is capable to perform any operation on the basis of given instruction. Means this is completely programmable IC. So our calculator is converted into the programmable electronic calculator. Okay, now we are not making it only calculator, we have to make it like human brain. Okay, so we have to add some extra features. So which type of extra features we should add? So our human brain responds to the interrupts also. Whenever I am working on particular task and meanwhile someone come to interrupt me, at that time I should entertain those person who is interrupting me. So we have to add this feature in 8085 microprocessor also. Okay, so for that we need one interrupt controller. So here is interrupt controller block. So in interrupt controller block there are 5 hardware interrupts called INTR, RST 5.5, RST 6.5, RST 7.5 and trap. Okay, so these are the hardware interrupts, so that any input output device which want to communicate with 8085 microprocessor can interrupt this IC. Okay, and one output signal is here which is called INTA. So this INTA is interrupt acknowledgement. So this is the response signal for acknowledging the interrupt. Okay, now another feature is here that is called serial input output control. We want to make some modification in this IC so that this IC should capable to communicate with serial devices also which are performing serial data transmission. So we have to give 2 pins called SID and SOD pins which will provide a facility to communicate serially too. Okay, now let us discuss about some extra control signals of this IC. So this IC is not controlling inside block only, so it should control those devices which are being connected with this IC externally too, isn't it? So for that we need some extra signals here. So first of all we will talk about supply pin. So it has plus 5 volt and ground pin for supply, and it has X1 X2 pins for connecting the crystal oscillator so that it can have some clock pulses, and on the basis of clock pulses it should respond. And it has also one clock out so that it can provide the clock signal, output signal for those external devices which needs some clock pulses. Now apart from this it has some control signals like WR bar, RD bar and ALE. WR stands for write enable, RD stands for read, and ALE stands for address / enable. So read write is used for set the direction of data bus, whether this microprocessor or this IC wants to read the data or wants to write the data. So on the basis of these signal it will set the direction of data bus. Now it has one ready signal so that those devices whose operating speed is lower than this IC can communicate and can synchronize with this IC. So for that one ready signal is here. Another status signals are S0, S1 and input output / M bar. So these signals are status signal. So S0, S1 will show the status of which type of operation is performing, whether the opcode fetch or memory read or memory write or tri-state buffer of the data bus. Okay, and IO / M bar signal is nothing but to selecting input output device or memory. So for selecting input output device this pin should be high, and for selecting memory for communication so this pin should be low. Now next is DMA control signals. So here are 2 signal, hold and hold acknowledgement. So hold and hold acknowledgement is for DMA controller. It is called direct memory access. So I will tell you about this in detail in further lectures. Now next are reset pin. So it has reset out or reset in. Reset out signal is to reset external devices which are programmable. So it is used for the external devices. And reset in pin is for reset this IC, means 8085 should be reset by external pin also. After applying logic 0 to RST in pin, the contents of program counter will be 000. It means that the IC 8085 will reset, means it will start from the first instruction. So this was all about block diagram of 8085 microprocessor. So students, if you remember this block diagram likewise step by step, so I hope you will understand or you will memorize this very easily. Thanks for watching.